you very much for coming tonight. And I know it's very cold weather and all this very hard sometimes to get to the home campus. And I really appreciate it that you guys come. Before we start, we have some of our sponsors here to kind of talk very quickly about what they do, and really appreciate what they have done for us and make this possible. And after that, we have Mr. Anderson here and going to share his knowledge and case studies that they have done personally and Mahout. And after that, we have a discussion. You can ask any question you want. And our goal is to get out of here around 47, 45, so that we can get on to live. And also, we have a wonderful staff and maybe one thing about the restrooms, first person first. David, there are more you can get out of here. Hopefully, you don't have to. It's cold outside. And if you're working at Home Depot, usually that's how they have to get rid of the coldest and rainiest day. That's a good thing. So, anyway, these are the restrooms. You can familiar with the campus. You go out and right on your right side, the restrooms here, and also if you need to leave, make sure you use the front door because the back door is into the parking lot, unless you park there. And please don't wander around the building. It's huge, you get lost. I'm working here about 2 years, I still get lost. So, anyway, when you get to discussion or if you want to ask a question, the great thing about this room is this device in front of you, just press speak so everybody can hear you very clearly. And, thank you. And is there any questions before we start with our sponsors? Alright. Well, most of our sponsors are not here. They are busy making money somewhere else. They are corporate sponsors, and they are very dedicated to helping this group, and they offer, and their main goal is not making sales, actually it's education of the community and education of the members. So we are working with them very closely, so hopefully we can come up with good classes later on, next month or next month after, maybe be over at the Space office. And yes, we appreciate that very much. The next one is their expansion, the Navigator to represent, and they are, again, one of our sponsors, and they are working on the BI and the big data projects on a project basis. Sprint, if you came last time, they treated us as a fantastic dinner. So maybe next time we should go there because they have a 5-star dinner, and, but they have a small facility. And I just want to explain something. My intention was to make this event today as a quarterly event, so just a lot of people come, but because of our speaker, we didn't really make it, the last minute, so we have to make a lot of adjustments, and hopefully next year it's going to be our quarterly event. And we are trying to get one of the most executives that we start with the data. So just stay tuned. And you said not in any particular order. We are here. Thank you everyone for Home Depot for providing such a wonderful facility and being kind of put up with my nonsense request left and right. So some of the Home Depot here, thank you very much. And K-Force. Here we have Ashley. So if you want to say a few words.
Thanks for knowing everyone. My name is Ashley Oman, Director of BI at Solr. We're a tech recruiting firm, and we're also building our solutions and advisory practice. So we are sponsored because we're actually very heavily invested in the BI community here in Atlanta. We provide resources to many of the top companies, including Home Depot, and we also speak and present at other industry events because we feel that we should share whatever knowledge that we have and feel very strongly about community education. So again, thank you for coming, and we have a team of people here in the front. We have several of our BI experts in our office. So it's a great night.
Well, Nosy is actually, if you don't know him, you already very few people that have that don't know him. His company is providing offshore services, and hopefully next time we can have them talk about it. HP Veritas are one of the sponsors, and I'm sure you all have a system, and we are trying to get them to come and explain the basics of the stuff. Maybe not the time, but nice you can do it really good. Who will be the method? Andy?
Hi, I'm Andy Neal with Proven Method, VP and account manager here for the Home Depot. We have a lot of BI work we've done here, MicroStrategy, Power OLAP. We also are involved with ab initio EDW work. We also do quite a bit with professional services. So we take on projects and do custom software development. So pretty much throughout the Atlanta area, it's really our focus.
All right. So review. Now we're going to talk about fun stuff. Mr. Barry Anderson is solution engineer at MapR, and I don't think this is something that we have to do develop
First time, huh? That was pretty good.
Okay. So, hi everyone. My name is Brad Anderson. I'm here from MapR. How many people have heard of MapR? Yes, one. Okay, good. About half the room. MapR is a Hadoop distribution provider. We're going to talk a little bit about that at the end, but as I run the Atlanta Hadoop user group, we're very aware of the meetups and how they sometimes don't have that vendor list. I'm going to try to do what I ask of my speakers and not do that until the very end. It will make sense at the end when we talk about some of the use cases. But we'll keep that till then. I'll follow the rules and have my red hat on, but I'm already not on. NoSQL is a movement that's happened probably gradually over the last 6, 7, 8 years. The tools that are coming out are better fit for the use cases that people are trying to accomplish. So in that vein, I ran a conference. It was I guess the second ever NoSQL conference in the world. The first one was out in San Francisco. So way back in 2009, in an auditorium like this, down at Georgia Tech, we had 14 speakers over 2 days, and it was really exciting to see the nation's market starting to arrive. We had 3 talks on Hadoop. We had Cassandra, MongoDB, Voldemort. I was working for a CouchDB company at the time. So it's growing from there. I think that Hadoop has gotten a lot of momentum. There are still tools that do exactly what we want for the use case we have in front of us. So we'll talk about some use cases and so on. If you're looking for me online, I, for whatever reason, only have 1 card left. You can look on Twitter or GitHub or Code and SlideShare, Blu-ray, most places. These slides will be available afterwards, so we'll go out to the group, but my email address is there as well. Did that last pitch? Were you guys aware? Is it too loud or what are we doing? We're good? Okay. All right, so we'll talk a little bit about the big data landscape, what I'm seeing, what Mapbar is seeing when you go out and talk to customers. I picked two use cases, one in financial services that I find very interesting for two different techniques that we use. And then because I was coming to the Home Depot campus, I wanted to talk a little bit about retail and some of the things we're seeing there. Very interesting use of graph databases. So, and then at the very end, I'll talk about platform considerations when it's time to put what you've done in your science project or your dev and test environments into production. There are things that may not have shown up during the proof. 3, 4, 5 months in, you really want to consider when you have to deploy it and have to deliver it, because distributed systems are a brave new world. Okay, big data is the term of the decade, I guess. I mean, this is hot stuff, right? It's gonna do your job. It's gonna make your coffee. It's gonna do everything for you, right? It's not all this shiny. There are still a lot of rough edges, I have to say. So, what we see in the market, the yellow line up there is Hadoop. You have lower runs of Mongo, Cassandra, and Ringform. There are web visits to Mapbar. We cut out the ones from China. There's hardware and software costs going up, and then I think just a random graph that goes up from the left to the right, because all graphs have to go up from the left to the right, right? So big data is here. Hadoop is here. But you have to kind of ask, where are you on this chart? And anybody know what this chart is? Gartner type cycle. So, depending on who you talk to, most people think that big data or Hadoop or Cassandra or all these different tools that we'll talk about is just getting to the peak of inflated expectations. That there's a lot of promise. Everybody remember what happened with cloud. Cloud is now here. I think we're kind of reaching the slope of enlightenment on cloud. We have Amazon, we have Rackspace, we have Google Compute Engine, and people are starting to use those right now. But big data, there are some companies out there that are using it with great effect. There are a lot more companies that don't know exactly what they want to do, and that's okay. So, one of the interesting things that this is not new stuff, right? People have had data sets that are larger than the servers that they have at hand forever, right? So you start buying new SANs so that you have more disks spinning, get the data off the disk faster, database kernel. It's not a big problem. We have new tools now. And the tools are much more exciting. Right? Think about building a house with that hammer versus now the nail gun. Although this is Home Depot, so you guys probably know it's a finishing nail and not a turning nail. So caught me a little slack here. So, and I was talking to some folks back there around the beverage area, and they were saying, in the last 5 minutes with you talking, I've overheard 10 different projects, 10 different tools to use. And it's like that now. I've been talking for 10 minutes now, and I've mentioned 5 or 6 of them myself. Which ones do you use? Right? How do you know which ones to use? Do you use Hadoop? Do you use Hadoop with Yarn, Mesos, Mahout, Solr? So, anybody in the room know what every single one of these are? Not too many. what I usually do is then turn it around and frame it in questions like this. Right? How much data do you have, or will you have? Sometimes you're planning a new greenfield project and you need a lot more capacity for future data sets, right? We're expecting to either gather more from external sources or generate. Sometimes you generate more data from telemetry operations on your manufacturing floor, right? So you have to kind of factor that in, right? So how large is what you're going to store? How large are the questions that you're going to ask? Right? Is it you're just going to go into one piece, or are you going to just scan the whole thing each time? Right? And then, when does your audience lose interest? How fast do we get the results back? Right? Is it microseconds, milliseconds? Is it 100 seconds or so that the analysts don't get bored? Or can a couple hours or a couple days be enough so long as you actually get through the whole set? So we came up with this slide. I think it needs some formatting, some style sheet love, but my favorite question is the first one, right? If you have under 10 gigs, or maybe even under 200 gigs, and there's no hard and fast rule, but the relational database is a tool that's been around for 40 years, right? It's been hard, it's been optimized, it works in production, it works on just about every workload that we've thrown at it. It's only in the last like 5, 6, 8 years that some of the things that we've thrown at it don't work. The queries return estimated to in 3 to 5 years. And that's not going to work, right? But for most things, this is still a pretty good hammer for that nail in front of you, right? For a lot of people, they still don't know that they have these tools out there, and they're still using relational databases. That's okay. These things are just fine. In fact, I don't think I've ever been to an Mahout customer or any big data site where the relational database was swapped out completely. Right? It still is talking to all the systems that you might have on your presentation tutor. Right? You might even be accepting data from relational databases. They have to cache it. There's a little business logic there. Why swap it out if you don't have it changed, right? To the right, as you go down the rest of the tree, there's pain because these things are young. These tools are young that we'll talk about, right? They have rough edges. They're not enterprise ready yet, some of them. So just be careful if you want to use one of these. Think about, can a relational database do this, or is it going to be enough? Right? I know it's kind of shiny to be a data scientist or use big data tools, but there's business at risk, right? If you want to raise revenues or cut costs in some meaningful way for your business, relational database is still a good tool. Okay, so let's say you do have some of this pain and you're willing to take on these new tools. What is the size of the query? And if you're going to go and want to do really fast lookups on a massive data set, but you know exactly the coordinates of where it is, that's a problem we call big storage. And Cassandra or HBase, Cassandra is sort of medium data, medium storage, but HBase is pretty big. So this is a key value store, and you can go straight to the coordinates and pick out a multi-petabyte data set in 10, 20 milliseconds. That's pretty good, right? It's when you have to go across the whole data set where things start to be interesting, right? If you're going to do one pass over the data set, one time only, and then after that it's just data exhaust, that's a streaming computation problem. And there are tools that are coming out of Twitter, Yahoo, and LinkedIn that can do that for you, right? There's Storm, there's Sansa, there's S4. And these are for, if data shows up on your doorstep and you need to do something with it, you do it probably in memory, and you might archive it later, but you're basically done. That's a streaming workload. But when your data set's going to be queried en masse over and over again, you have some other choices there. So that puts you into pretty much Hadoop, I would say. And if you have massive data, you need to scan it each time. The parallel nature of Hadoop is what we're looking for. So think about interactive Hadoop, which is a new area of Hadoop itself, which is also good. You can't keep track, right? So you have tools like Hive or Batch, right? That's going to be MapReduce here. But now people are making Hive faster, or they're making SQL on Hadoop or SQL in Hadoop tools like Impala. Facebook has Presto. The Berkeley Ant Lab is coming out with something that it's out. It's called Sharp and Spark underlies it. Apache Drill is a project that MapR sponsors, and that's going to be pure NC-SQL, not just HiveQL. All of these are very exciting because you're running something that's very familiar to all the organizations out there. SQL, right? Everybody knows SQL. And you're running it on Hadoop, right? These tools either turn it into MapReduce for batch processing, or they have their own execution engine, and you still get the parallel qualities of Hadoop, right? And so when throughput, not response, is your goal, you go with tried and true MapReduce, and there are things on top of MapReduce that make it easier, like Hive, like Pig, and like Cascade. And these tools are best used when you need to get through it, you need to do it in mass, and you're not really worried about the time, right? You can run for 6 hours and it's not going to be a big deal. The other one I want to talk about is when you have to follow links between your business objects, like a customer and a checking account and a transaction on a checking account. You want to follow the links, you want to decorate the links with properties too. That is death by join in a relational database. And so graph databases have come out, and they're very exciting about that. So what have you guys in the room been doing for the last 40 years? Or the industry has been doing? You guys don't know that old. You have applications with function. They talk to a database that, where the function lands, right? The queries that you want to ask. And then you have some sort of distributed storage that spins the disks and gets the data off the disks and into the database brain, right? Into the RDBMS. And this works up until a point when you have the ability to stripe the data across multiple machines. The file system does that for you, and you have the ability to stripe the function, the query you want to ask across all those machines. Interesting things can happen, right? This is distributed computing, and this is how we're getting through massive data sets faster. Right? So I have 2 use cases, and please be interactive. Throw up your hand and then hit the button there. Both of them will not let me use their name, but I can kind of cheat, show you the card holder of one of them. So they have big data problems, right? They have the My Offers program, where they can scan all of the purchases that you've ever made on your card. I believe the past 20 years. And they have their merchant designation, meaning they know what the merchants sell. This is a sushi restaurant. This is a golf course. Right? So they also have the ability for merchants to create special offers. And their main goal is, or at least the recommendations to come out of it, is that throughput is important. They need to get their algorithm to calculate what was the next most interesting thing for Brad to buy. They need to get that algorithm through all the data. So throughput is important. So let's use this large amount of data to get through a recommendation engine. Right? So the behavior of a crowd is what helps us figure out what I'm going to want to buy next. What is a relevant offer for Brad? Right? Mahout is going to be the library on top of Hadoop. Again, you'll find that the names are Python. Sometimes we call it the Hadoop Zoo. That's big, I, Glow, and Scoop, and Z, all these weird names, right? Mahout is another one. In fact, I think there's a debate on how to say it. Is it Mahout? Is it Mahout? It's a machine learning library, which has like the reincantation of artificial intelligence, right? In the early 90s, it sort of died out, and they call it AI Mentor. This is like the next iteration of machine learning, is where you train the algorithms with the data set that you know is right, and you put the new transactions through, and then spit out a result through classification, through clustering of customers, and clustering of transactions, or of network behavior, or recommendations, right? What is the next best behavior? So Mahout is going to be where we use the algorithm, and I'll talk about the use of search or Solr machine to deploy this to the field, because the goal is to figure out what I want. And when I travel, when I land in Phoenix, it has a database. It has the ability to push these offers to me, right? Because they know that I like golf, they know that I like sushi. I land, I get the 5 offers that are relevant. I go to the merchant, redeem the offer. The merchant gets the business. I get relevant offers, and the credit card company gets the transaction fees. So pretty much everybody's winning here. This is pretty exciting. Okay. Recommendations, really quick. Alice had an apple and a coffee. Charles had a bite. Bob had an apple. What else is Bob? What else do we have? Machine learning.
No, it's a typo.
So you can get useful indicators from these behaviors, right? Look at your log files for history. I don't want to get too much into the math here, but transform it into a co-occurrence matrix of either items by items, or you have like users by items first, and that's moved into a items by items matrix. And here are some of the classes that we use. I'll say that here are some of the classes that we started with in Mahout, and then the company obviously grew out of these and customized. And that's a common pattern where you start with something that might be publicly available in Mahout, one of these other libraries, and you optimize to your specific situation. So let's take a look at this. Here's now where you have everything running the way you want. You're getting a massive set of recommendations ready, and that one big hammer we have, the relational database, right? Everybody uses those, right? So let's have the application servers that are serving the request from my phone or pushing out to my phone. Let's have those continue to talk to DB2. We have massive amounts of DB2, okay? There's a mismatch between Hadoop and relational databases now, in that you need to export the data out of Hadoop and put it into the schema, right, the rigid schema of the relational database with DB2. So this takes 4 hours to make the export file, and 4 hours to then import it into the proper tables in DB2, right? Well, to step back and reimagine this, why not use the search engine and create an index of the recommendations and have the app servers just hit that. Right, so this is what we call search abuse. Google uses it. Everybody uses search for, a search of a word, and you'll find the documents that might have that word in it, or a product that you might be interested in buying. We're using it to index the recommendations, index the content that you want to serve, right? So that you get an under 50 milliseconds response time from you know, Brad needing to get an update on his phone and push in some offers, right? So the update of the index after you run another recommendation in your Hadoop cluster is 3 minutes, right? This is not the 4 hours and 4 hours as before. So you're deploying your recommendations a lot faster. And you're cutting costs because you don't have to have DB2 in your picture anymore. I'm sure it's still around there, but this is pretty powerful. This is a use in a massive scale of some pretty new technology, but you know, it's hard. It's in production now, and it is a key thing for this company. Okay. So NDA has me being a little bit careful here. So what I've done is I've kind of spun this around to what the equivalent techniques would be for Home Depot. How many people from Home Depot corporate are here? So forgive me, I'll also use your logo here, but this is not an internet-wide presentation here. So, okay. What's that? Yeah.
So this Solr deployment you had, can you talk a little more about it? You showed that it is part of your Hadoop cluster, or was it a separate, sort of a Solr cloud, or how did you deploy the Solr piece?
In case you guys didn't hear that, what is the Solr routine portion of this application stack? How do we integrate this? So there is a feature in MapR, and you guys should know that there's a slide on this later, but we rewrote the file system of Hadoop, right? It was meant to be swappable, the original office of Hadoop, and it to be rewritten for different purposes. Nobody really went ahead and did that ever, other than MapR. And so we did that to have some enterprise features and to harden it. We made it read-write, we made it POSIX compliant, and that allowed us to add an NFS interface to it. It's not NFS is the file system, it's an NFS gateway into MapRFS. And that is very interesting because, yes, you can co-locate the Solr routine bits, right? The indexing can happen. And it can actually happen on 1/5 or 1/6 the nodes. You can have one indexer node for every 6 nodes in your cluster. And then all 6 of those nodes can serve the reads, right? So the indexer, usually in HDFS-based Hadoop, you would have every node has to index the documents and put them in HDFS. With MapR, you have this ability to have 1/6 the node indexing, and all of the other nodes can see the index that you just wrote within like 5 or 6 seconds because NFS access, right? So you have the nodes, sorry, the read for the portion of Solr that's serving the reads from the apps can hit that NFS mount on the internal nodes of the cluster. And you don't read and service that to the apps.
Okay.
So that's a kind of a novel use of NFS within that part. Again, I mentioned Storm and other streaming technologies. Those can also live on the MapR cluster and write directly to the file system because as HDFS is a write once and then read only after that, MapR is true read-write. So you can actually do real-time workloads, like millisecond type work down in the file system with systems like Storm or S4. Good question. See me after the person. Okay, major retailer, and again, I reframed this in Home Depot terms. So point of sale history of gathering large. You guys have some data laying around? Yes. There are product or item details, right? The POS. transactions have items on them. And you can also draw corollaries to say what the goal is or what the end project might be, right? By these certain items, we know that you are in the backyard, building a deck or something like that, right? So there are batch uses and batch query times that are acceptable, and there's some real time that we're doing that is also very interesting on this. And it's classification, and again, it's a recommendation engine. So, but the big technique here is to use a graph database. And these are graphs right here, but they're not graph databases. And you might think this is a weird slide, but I was up in front of the crowd and I was really way off on it. And I was like, I was working myself into the city. I was like, yes, graph databases. There, hand goes up, says, we just use Excel to make graphs. So, I'm getting myself, and I thought I would just put this in earlier, right? So graph databases, to save a little time, are mostly doable with relational technology, but not everything is doable. So in graph databases, you have vertices. Those are things, those are objects of your business, like a customer, like a POS transaction. And I'll show you a live demo here pretty soon. Right? The vertexes have IDs, and they have properties. And so to do this in a relational world, we have a table of products, say, and product has a name column and a born year column, right? Just like this. And then you have another vertex, number one. This has a name and a born, right? They don't have to be the same. You can have different key value pairs here. But the new item in a graph database is that you can draw a line between them, which is called an edge. And that's the relationship between these two business objects that we have. Edges have IDs as well, and they also have labels. So you can say that Faunus, we'll talk about Faunus in a minute, and it was born in 2012, and it needs, or it depends on Hadoop. Hadoop is a dependency, the Faunus runs on top of Hadoop, so you can put depends on the label. Edges also have properties. And the cool thing here is that you can put these properties on the links between the objects, and you can use those in your queries. So think about doing this in a relational database. You have customer table, an accounts table, and if you wanted to link them, customer has some sort of foreign key in between, but that link in that query could have no properties on it unless you introduce a third table. That third table can then have properties and have the two primary keys linked. And so this quickly, when graphs grow, and grow, evolves into joint health, and you're screwed. And your queries are never turn a millennium, century, just too long really to gain any insight from your data. So, master data management. Anybody know of the discipline of master data management? You guys have MDM products in-house in Home Depot? Can somebody give me a definition of it? Would cleaning up the dimensions of your data warehouse, like knowing that this is a household, knowing that this is a deduplicated address in one of your databases, is that kind of some of the tasks that you guys do for master data management? Keep that in the back of your mind. When I'm going to make the graphs very big, because I'm going to basically marry master data management and your enterprise data warehouse in one data store. That's one of the powers of graph databases, is that we can go ahead and add those in as well. So what are your other options as far as graphs? I shouldn't say other. What are your options, right? Neo4j is the market leader. It's an open source database. You can get a commercial license for it. One of the problems with Neo, at least in my world, is that it doesn't scale past 32 billion things. A thing can be a vertex or an edge, or there are limits on properties of edges and vertices as well. So it's basically a single server graph database, and you can do master-slave replication, and you can scale out your reads, but the whole graph still has to fit on one box. So it's like the Oracle model of scaling the box up to handle queries that are coming, right? And it's great. It is a fantastic graph database. I would recommend it. Just like I would recommend a relational database when the data is pretty small. You have some other ones up here. FlockDB is a graph database run out of Twitter. And their problem was that they don't need to follow multiple links. They just need to follow one. And that is, who are your followers? Because when you tweet, they have to follow each of those links only one hop and notify you or put it in your timeline that I just tweeted something. Right? And I gave you my Twitter handle on the first couple slides there. Just be aware it is PG-13 at best. I like to have fun on Twitter. So, the bottom rows here are more for graph analytics. So think about MapReduce and going through and doing a full scan of all your data. Giraffe and Hama are implementations of Google's Fraggle paper. They didn't give Google never gives the source code. They didn't give the source code to GFS, Google File System, so we had to make Hadoop file system. They didn't give the code to MapReduce, so we had, the open source community had to be coded. Same with Fraggle. It's a technique called bulk synchronous parallel, and it's how to go through a graph and all these links, and it's more of a programming framework. And so those are some of the implementations. And I have heard good things about Giraffe recently, ushering. But the ones that I'm using now are sit on top of either Cassandra or HBase or LabR, and they are Titan, and that's for the holding the graph, holding the vertex and edge and properties. That holds it all, and that allows you to load in and out. Faunus is where you want to do some analytics or bulk loading, and Faunus uses MapReduce to, say, scan your relational database or scan whatever data source you have of your graph and bulk load it in. Or if you have an algorithm you want to run on a massive graph and you want to parallelize that across the graph, Faunus will do that for you as well. And Faunus is, strictly runs on Hadoop because it's MapReduce, right? And then, there's no real good solution for splitting up a graph in a distributed system. Remember how I said Neo4j is a single server only? It's for good reason. When you split up a graph, you have hard decisions to make and trade-offs to make, because you're now talking about part of the graph is over here, part of the graph is over here, and so if you're doing an algorithm that traverses and oh shit, I have to go hop over here now, it's called an NP-hard problem, and Titan doesn't get around it, nobody can get around it. Right? Titan cheats a little bit and uses a big data storage engine on the back so that it looks like it's on one machine. But certain things are very good, you can scale, and certain things are still very bad. So you have some reversal algorithms that might be pretty slow. Well, Solr is a way to take, say, a trillion object graph and move, say, 1 billion of those objects into one box, compressed in memory, run a traversal algorithm, get your results, and discard it, and then maybe move another area of the graph. If you know that sub-graph is going to have the data you need, Solr is an excellent tool for that. So there are trade-offs, kind of like the cat theorem. Let me show you guys something. Again, this is customized for Home Depot here.
So we have a vertex. This is John, he's our customer. He has a point of sale transaction. Number 1, 2, 3, 4, 5, it happens in the bucket reload store. That's actually the closest one to me. The graph can link that for us. You now see properties on that link as well. This purchase was made by John. Made a couple of other trips into the store. Those are also linked to him. Maybe he's using the same credit card. I don't know how you get identify customers. This is totally possible on a host of different systems out there. The part that I was talking about is very interesting for graph databases. You can not only do the MDM bits, right, the household, the credit cards, all the business objects that you might have, add in the individual transactions, or in your case, the line item products based on, right? Let's link those to first. So we'll link these transactions to the first, these items to the first transaction here. So this is bath powder route. This is a drawer pull. This is a trowel, another drawer pull. Right? And again, this is a visualization. This isn't really a working graph. This is a visualization of it. And let's see, you went in, this is tomorrow, so false data, right? But tomorrow, 11:40, you go in, and then forgot a couple things, so you go in again, right? In the database, in the graph, we also know about Jane. That's your wife. That's his wife, actually. So we're starting to get a picture of the household and what they're buying. She might actually have some transactions that she did at a different store. Doesn't matter. Stores can be vertices as well. I chose to represent stores inside the POS transaction that are depending on your queries that you want to run. It might make sense for a store to be a vertex. You have links to the customer, links to the transactions. Now, take the business data that you already have, right, a list of products, and put them into buckets that mean the projects that people are working on. So, this is a bathroom remodel, and the label now is purchased for, so you get that powder out for a bathroom remodel. Turns out you get a whole bunch of other things too. They might even be in different transactions, but you're getting a bowl sink, a flush toilet, and a seamless shower door. They're not only linked to this POS transaction, but they're linked to this bathroom remodel. Okay, so what's the use case? What do we do with this? Well, there are two things, right? So in batch mode, it's not that important if John has already left the store after these 3 transactions. Even after 2, you can see that he's probably doing bathroom remodel. And so it might make sense to push his wife an electronic offer for some of the more expensive bathroom finishing items, right? Just 10% off, 20% off, something like that. Because you know the household, and you might know who would be interested in the finishes, right? That's one use case that we've seen. You can certainly, if there's an in-store app experience, you can actually push the offer to them right there. There's another retailer we're working with that has outfitted the store. I don't know your status on that, if you've done that or not, but outfitted the store to know that I'm hovering near an end cap and facing right at it. And I've gone back a couple different times on the same trip, and I might need a coupon to push me over the edge to actually pull the trigger on whatever's on that end cap of the store. So it's pretty exciting times. The other one that
that I think we can start to do is more of a real time. And this is a bit a different phase for the retailer that we're working with, but you see 2 transactions, and then you see a third one happen a little later in the day, maybe you forgot some things. If you know, if you can do an analysis in non-batch time, right, in real time, you already know he's working on a batch project, you already know some of the items that he might be missing on transaction 3, save him a trip, ask him if he wants to get that item. Yes, okay, you need that. What was I thinking, right? So, that's no problem. We can just bring that up for you here and send somebody out to the car with the item for you. So, this stuff, I think, would have been crazy. Even as recently as 2 years ago, 1 year ago, right? They're happening now. Dare I ask, are you guys doing anything like this at Home Depot?
So, we are talking about the sales offer and how we can consumption. So, what we can do is not need capital because we can do it by reporting or any kind of dashboard kind of thing. We can do, real time. It's possible. So, why do you need capital?
It's possible, you say. So, it tends to be very difficult or very cost prohibitive at scale. So, the MDM systems that I was talking about earlier only have, they're not even using graph databases. Some of them are starting to, but they're only representing the objects of the business, not the line item detail, right? Not the, say, for a bank. You have an object for a person and an object for a checking account and all transactions. Nobody's putting transactions through the graph database, right? Nobody's following this transaction to this account, to this person, to this account, go all around and around and around. This circle of money that looks like a washing machine, and where the money comes all the way back around to the original person, squeaky clean. I don't know what that query looks like in a relational database. I don't think that those dashboards or those tools are out there to accomplish that query at the scale we're talking about, right? We're talking about billions of, well, let's just take Bank of America, right? 20 to 30 million customers, I think. Customers, I think there are maybe 40 to 50 million accounts. How many transactions do they have? Right, so now you're talking about fact tables in an enterprise data warehouse, star schema, that, how do you go find patterns, right? You have a trillion row table joined against a billion row table, that's like a subset of your analysis. And that's not going to return in time.
Not kind of that, because we have right now on the board as we find a lot of core customers. Because each core customer wants to repeat something. Like core customer means who are buying a bulk. So sorry, anybody who is building a house, they need so much material for building a house, so they buy a bulk. So we have all the mechanisms like processes where we can go by from retail or some other process, which find out what the core customer, which core customer buys a lot more people. And then they can send it out to the customer special offer. If you are the way to the account. So I'm just trying to get that one. If you get into that area, how we should improve our process and how we can see when it goes to the NCM action, we will see the food customer is my game customer. So how we can see this one?
So, can I add to that?
Yeah.
So essentially, my take on RDBMS is straight pipe long hole, right? What you're elaborating on is your executive at the top wants quick solutions. Time to market should be pretty, I mean, somebody just invented a requirement just now, who wants a delivery in a limited amount of time. If you were to go down the relational path, you'll have an ETL tool going on, you will be having a data model involved in that, and then you'll have a subject matter expert, just like, music training, you'll have to model those new facts and dimensions and whatnot. With this approach, I think the cost associated with doing all of that is pretty, what would you say? I mean, compared to the RDBMS approach over here, the cost will be very minimalized. So just the time to market factor. One aspect is the processing part, which is, hey, how quickly can I process this information? And there's a term called impedance mismatch. That's where the square peg download thing comes. RDBMS is not designed for this kind of stuff. If you see those connect by queries, parent-child relationships and travels through all those, they become a nightmare. But the other side is the cost also improves how fast you can deliver to the business plan.
I'm going to expand on those two, right? So the cost is one thing, right? So Titan is free, Faunus and Solr are free. You're looking at Hadoop solutions at $500 to $1,000 a terabyte, maybe. If you've done disaster recovery and have mirror sites, the data, 300 to 500. I mean, I've seen them lower, right? You're in that range. Whereas I've seen numbers for Teradata or for Netezza, Greenplum, that are anywhere from $10,000 to $15,000 a terabyte, up to $60,000 if you have full redundancy in data center replication. $60,000 a terabyte. So the cost is definitely one driver of all of this. Sometimes solutions are, 20 times. One of our largest customers is Cisco, and they actually achieved 100 times cost savings over their enterprise data warehouse with their new solution. So the cost is big. And in an hour that I have to talk to you, I can't go into detail on graph databases, but there's a powerful graphic out there that I should have in these decks where the cost of traversing 4 of these links at scale in a relational model of a graph is about the same, right? It's all kind of 1 to 2 seconds or faster. But then when it just starts to grow and grow, and you see 8 seconds, and then, for 5 degrees of separation, 6 degrees of separation, you start to see minutes, and for 7 degrees of separation, you start to see hours. And so the joins start to kill you at some point. And for banks doing anti-money laundering detection, they don't want to stop at 6 or 7 hops, because the guys doing the laundering might have gone 20 or 30 different steps to hide their tracks, to move the money from account to account to account before it's squeaky clean. In a graph database, following those links is basically static time. That same query for 20 degrees of separation is still going to be 2 or 3 seconds. So it's the more advanced uses, and I'm advocating putting more and more of your transaction detail in the graph. And so that might not totally answer your question, but that's where my thinking is on it right now.
So, I'm assuming that if you implement a graph database, you're not using traditional SQL query languages to pull stuff out of that database, right? Thank you.
That's not my whole answer, by the way. I will get there. I'm going back to the slide right there.
What makes it?
Yeah. Here we go. See me after this one. Probably attached to it.
I would like to ask some points about what is being done at Polygon on your website.
Okay, can you repeat the question?
I would like to add some points like what's being done at Polygon. I will stick to the technologies and the business ideas. Like we're using we're consolidating customer data, which is I think what we call as master data management. So that's being done at Hadoop level to gather all the customer details And that's being pushed to Cassandra for faster learning, so that from store you can actually ask the customer, find the customer and tell just the customer contact details visual here. And apart from that, there's something called transaction matching. Like every customer, what he purchases, how much he adding value to the retail business, especially Home Depot. And also we have a module to process the household. Like which customer is related to whom, how can we actually recommend them what we are talking about. So that is also being done, and we use just Hadoop and Cassandra so far. Because the two models apart from that, we do have sites with the graph in there. And the graph is totally based on the product. Like what are the vendors we have, what are the items we have, what markets they are distributed in, so we can play faster. Like the edging work, all concepts are used, and we ended up in some problems like hotspots and of course servers will be used. So that was a POC and it is not being taken further, but that has been taken further, and we create a link between the product and the market which was for POC and the customers which is already being processed, which means we can use the transaction mapping and household and the customer contact details. If you relate all of them, this is possible for the business to now.
You're going to want to avoid the hotspots, right? And there are ways to do that. Titan is pretty young. They're still evolving. They're still trying to get their indexing scheme right. It sounds to me like your use of Cassandra is, and Cassandra in general, in my opinion, is an index creation toolkit.
Yeah, we have that just to store the customer contact details.
And that's
also very easy.
Yeah, and so you're pre-computing, and then like the POS or whatever going to hit that data set knows exactly what to ask for, and that's either an HBase or AppR tables or Cassandra. That's that big storage problem that I was talking about there. So that's a pretty good use for Cassandra. Where they might not know or be able to pre-compute, but we still want to follow some links in a graph, you're maintaining a query time that's just not possible in relational. So that's one of you wouldn't necessarily have to pre-compute as much to put it into a graph that still has some reasonable query times for the application. Anyway, you guys have probably read some of these. This is a graph query language called Gremlin that's used on top of either Neo4j or Titan. And here's an example of a Gremlin query that is so let's just do the top here, top line, g.v.add, right? You're looking for vertices that are of type dot, that have an in edge that is father, and an out, and we follow that, right? So you start at Jupiter, Neptune, or Pluto, but the only one with an in the father is Hercules, there's Jupiter. So then you follow the father back to Hercules, and you follow the out to mother, which is Alan, I can't remember. And then ask for the path, right? The other thing to notice here is that this is a MapReduce job. This turns that graph query, just like Hive turns SQL into MapReduce, this turns graph query into MapReduce. And in the end, you get the IDs of the vertices, 1, 7, and 8. That's the path you follow, right? So that's what you ask for. Pretty simple, but that's basically how it breaks down. The back-end storage for Titan, we sort of hinted at it, but good news, you guys have Cassandra in-house. It'll work. HBase will work. And single server stuff, you can use Berkeley DB. Because HBase can work, AppR tables can work. And we'll talk about how those are very interesting. So the pros of Cassandra, pretty easy to set up and work with, pretty easy to reason about. It was made at, the distribution layer was made at Amazon to make their shopping cart very highly reliable. If the shopping cart doesn't set right, they lose a lot every second. So they have a system for it. Sandra used that system. We used a key value pair system on the data storage side. It's an eventually consistent data store, so there can be some issues, although I don't like to list that as a con or a negative. I know Dynamo systems, and it's really only consistent for milliseconds at best. So it's a pretty good system. It does break down at the scale that we've seen. We have clusters with north of 2,000 nodes, and with the quorum messages going back and forth to different nodes for reads and for writes, that gets bogged down unless you have a serious network. When we talk about that gremlin query being broken down into MapReduce, Cassandra is not all that close to a Hadoop cluster, and so you have this this thrift finding in the Hadoop that is kind of slow and shape. You have to deal with that. There's an anti-entropy process that you run every once in a while to kind of clean up your data, but there's still one bug that loses data. Hopefully you guys are not getting that. And it's really good for lookups, what you want to know. The minute you have to scan across a range, that's pretty terrible performance. HBase, you now get a really good tight coupling with Hadoop, right? Running on the same cluster, or at least it could, but there's a best practice that says you should separate your HBase and MapReduce clusters. So if you get really fast gets and puts, I would argue that while Cassandra might be medium data, HBase is truly massive scale. You can do many trillions of rows, many millions of columns, and it will work. It will find your data very quickly. There's some operational concerns. These things called major and minor compactions. Because HBase has to live on HDFS, it can't change the file underneath and override it, so it has to append on. And we have these old stale records, and so you have to blow through the file and recreate it on disk. That's called compaction. That takes your read latencies from about 10 to 20 seconds up to, who knows, something bad. And so it's effectively downtime. When you lose a region server, you have to replay the logs to make sure it's consistent. Sometimes that'll take 10, 15, 20 minutes. It's seen to take 3 hours before. Any table in that region is unavailable while that server recovers. And it really sucks at data center to data center replication, whereas Cassandra is quite good. Now I got to get the hat, sorry. And I did try to pick some cons. Those are weak cons. So we've used the changes in the file system to make HBase better as well. We have amazingly fast gets and puts. We also have the tight integration. You can actually coexist your MapReduce, like the Faunus queries running, on the same cluster as the Titan graph. Instead of 2 to 3 column families as a best practice, we can do 64. We don't have compaction. We got rid of region servers. They nugget our metadata layer. And we do data center replication extremely well by only shipping the parts of the file or the parts of the table that have changed. On spinning disks, we're about 5 times faster than Apache HBase, and on SSDs, we're about 10 times faster. It is a Hadoop cluster, so it is somewhat difficult to set up, and then just like HBase, we compromise availability. So if there's a network partition, we will survive that, but parts of the cluster will be unavailable, and that's the trade-off that the Cassandra makes versus HBase and not our tables. We're already into that happening. So to reiterate, to talk about why the things you want to consider on our platform, MapR is a full Hadoop distribution. We have a data services layer that also has an HBase API. We talked about NFS. And because we have the HDFS API that's 100% compliant, everything above that, right, MapReduce, cascading, everything above that can speak to the MapR file system and think that it's Hadoop. It's just more resilient and so on. Here's an image, right? We talk about the architecture, the engineering effort. It took us 2 years in stealth mode when we started in 2009 to 2011. We were building a foundation for some really, really big data stores. So that takes some doing. I think this is those are the powers that fall on board. We rewrote C++, there's my garbage collection, it's fully rewrite. It's awesome. I have that on for you. So,
One second.
what's that?
It's circumventing the file system. So your bullet point number 4, direct disk access. So there's no file system involved.
Yeah, actually.
Can you talk a little more about it?
Yeah, it's pretty clear on this slide here. So, you can see ext3 or XFS or JFS or whatever you want to use, ext4, like a Linux file system, right? That then goes and formats the disks. Just like Oracle, we don't have one. MapRFS owns the block device. So we format the drives, right? That's what we did in our first edition launched in 2011, right? You see the files are sitting in MapRFS, whereas here, the files are sitting in HDFS, which sits on top of a JVM, which writes to a Linux file system, which finally gets it on disk. Okay? To make it worse, HBase is sitting in JVM, so your table is all the way there, many layers.
No, but with the HBase read short circuit, really you're going from HBase to ext3 really. With HBase read short circuit, if your data block resides on the same instance as where HBase
You go directly to the H file. You can't.
So you're actually going directly to the disk in that case through ext3.
In that case, yes.
So this MapRFS is that's the magic sauce really. I mean that's intercepting and writing that block over to the other three. I mean the metadata about what's being persisted on the disk is replicated to the other three instances.
Just like HDFS would do, we replicate the data 3 times or however many times it's configurable. Yes. We also got rid of the name node and strike the metadata about the cluster across the nodes as well. Now, you can see that in our latest release here, everybody might not know what an inode is, but in the file system, file is an inode, right? In MapRFS, a table, an HBase table also gets an inode. It's like a first-class citizen. You can use move or copy or set or off or ref. You can use these tools on a file or on a table directly. And so you have this unification of tables and files. If you have an application that's going to deliver this coupon push to the spouse or right? You might have some files that service that you can map reduce on. You might have some tables that are doing fast hookups or those super tables. Those can live in the same volume and be replicated to another data center, right? That is our special sauce, right? Here's some of the results briefly. You see that the MapR latencies are very consistent. We don't have these compactions or these different spikes of read times going crazy. It's actually a better site to see on SSDs. SSDs were spindle disks. And this is again a Unix workload. This would hold for any HDFS-based distribution running Apache HBase. So, one last thing, I heard at the beginning, I was talking to some people before we started about a lot of noise in the market. Here's what's happening in the market. This is where things get disingenuous and kind of mean-spirited, right? Greenform and Teradata and Exadata and Pisa, they all have their partnerships of Hadoop. And they all say, if you'd like to do some archive, if you'd like to not use our really expensive systems just to store it, go ahead and use this Hadoop over here on the right side. Okay? But keep all your analytics and keep all your production stuff on very expensive appliances. And we think it's disingenuous because if your Hadoop is enterprise grade and you can do more work in that Hadoop system, the meeting that I sat in once that cleared this up for me was the Greenform guys were complaining that Greenform and EMC used to resell that up. And there was many millions of dollar deals getting knocked down to 1 million, and the rest of the work was put on that bar. And the sales guys just didn't like that, right? Teradata is the same thing. They're not going away, right? We have massive Teradata and MapR installations where we just offload a lot more of the work that Teradata was cared for, but they're still involved, right? There's still the SOX compliance side of it. There's still the part of the stack that serves the applications and does some serious analytic work to it. So it's a little disingenuous. And so I'll do one other slide. More things can happen on a platform when you engineer it from the ground up, right? You can have the batch, you can have file-based apps. I love all SQL and database things that are happening on Hadoop. You saw we can do search, stream processing, and storm, to include graph databases. We're looking forward to a lot of these use cases happening and really making a difference, either cutting costs, driving revenue, or both. So, any other questions? You're a little short on time. Yes.
So, thank you very much. I wanted to see your opinion about an industry accepted methodology, similar to Kimball or Inman type methodology, maybe how blue data and blue maybe impact those types of methodologies. Are those methodologies still true today? Or is the landscape traditional and by the warehousing?
Thank you, Dave. Yeah. So Ralph now works for Informatica, and he's begun in the last 3 or 4 years talking about this stuff. I think he's seen some of the power of denormalizing, right? When the joint's going to kill you, and storage and compute are essentially free. There's so many disks, there's so much memory, and each of the nodes has, 12, 16, 32 cores. Compute is free too. So if storage is free, why not just duplicate the dimensional data with the facts? And he's okay doing this if you go large enough that denormalization is going to stay. Like if you are always doing the customer fact table in this way, and you have these analytics that run on top of that join, go ahead and materialize that join into another file or another kind of table or another maybe it's an HBase or some type of structure, and then base the rest of the analytics off of that. His model is breaking down at scale, and it seems to be okay, but I don't know about but yeah, they're recognizing that, and here's a pattern that we see over and over again, like data warehouse offload. The cluster, the Teradata cluster at Verizon had 70% of the cycles just doing ETL. Right? Teradata is like amazing for analytics. Why pay fast stacks for an ETL tool? Do the ETL on 100 nodes in that R in a fraction of the time, and now you don't have to buy any more excess Teradata capacity for 5 years. That's savings in the digital age. So that's the most prevalent use case is ETL or data warehouse offload, and that's basically parallelizing the mundane transforms that you're doing to the raw data, put it in your tables. And then you have a relational database to do some heavy lifting analytics that you already have programmed up. So I'd say that's 50 to 60% of the people we know to talk to are doing that use case first. And then they go to some crazy recommendation engine, fraud detection, and what's not longer. Cool. Thank you, guys.